everyone. Welcome to today's summit, Hybrid Cloud and Cloud Database Preparation for 2022 and Beyond. This event was organized by the hardworking folks at Redmond Magazine, Virtualization and Cloud Review, and AWS Insider, who have brought together some of the best independent experts on today's topic. Many thanks to our sponsor, Rubrik, the Zero Trust Data Management Company, for making this event possible. And thanks for joining us. I'm John K. Waters, Editor-in-Chief of Application Development Trends, and I'll be your moderator for the first of 3 information-packed sessions. But before we get started, I need to go over a few housekeeping details. Each of today's sessions is being recorded for later access. Keep an eye out for an email with a link to that recording. It'll be coming your way within the next few days. Each of today's sessions will be followed by a 5 to 10 minute Q&A. You can type your questions into the Q&A box at any time. Please feel free to add your questions as they occur to you throughout the summit. We'll do our very best to get to all of them. Our sponsor, Rubrik, has provided some extra resources that can be found on the right-hand side of your screen. Please take a moment to check those out. As you leave the summit today, you'll be asked to take a very short survey. Please take a moment to share your thoughts and honest opinions. Our editors read every comment, and they help to shape our future events. And last but not least, at the end of the second session, second of 3, one lucky attendee will be receiving a Surface Pro 8, the latest release of Microsoft's powerful 13-inch tablet PC. But you must be present to win, so stick with us. And now let's get started with our first session, your hybrid/multi-cloud infrastructure and data. Wise decisions for 2022 and beyond. For this session, we called on Joey D'Antoni, Principal Consultant at and Associates Consulting. With more than a decade of IT experience with Fortune 500 companies, as well as expert certifications from Microsoft and virtualization software providers, Mr. D'Antoni is a well-known thought leader in cross-platform IT. He has worked extensively on database platforms and cloud technologies and has a high level of expertise in performance tuning, infrastructure, and disaster recovery. I know you're in for a great session. Take it away, Joey.
Thanks. I'm happy to be presenting here. I'd like to thank our sponsor, Nutanix, for helping today. One of the things I wanted to talk about that I think is really enlightening today, because we're doing this talk today, the day after, there was a big cloud outage. For those of you who maybe were on a beach somewhere yesterday, Amazon had a pretty big outage yesterday in its US East 1 data center. And I've got a column that's going to come out on Redmond Mag today. It should be up in a couple of hours, just kind of talking through that. And one of the things we're going to highlight here is a lot of the reasons why people do hybrid and multi-cloud infrastructure is to try to protect themselves from cloud outages. And one of the things that ties into that is it's just not that simple. Things are complicated. And one of the things that I always like to talk about is data is always the challenge. So it's very easy to put a stateless application anywhere, anytime. So if I have, let's say, for example, and I knew these hardly exist anymore, but if I have a static website where the content is what's written onto the HTML file, using an HTML file for your website, I can host that HTML file in Azure Cloud Storage, in Amazon's Cloud Storage, in Google's Cloud Storage, and even IBM or Oracle Cloud Storage, and I can load balance between all 4 of those, and that's very, very easy to do. Unfortunately, more business applications want dynamic content, right? So they need to connect to databases or data stores of some kind. And mostly I'm going to be talking about relational databases today, but even NoSQL data stores, you have issues. You have to think about how you want to construct your high availability strategy and how you want to protect that. But the key thing to kind of remember is, like, a lot of the application frameworks you deal with, and even things like backup utilities, weren't necessarily designed with databases in mind. Like Kubernetes is a good example of this. When Kubernetes was originally deployed, there was no way to persist data, which was kind of a limitation. And that was very early days of Kubernetes. Initially, it was really designed to host web applications. Now you can have persistent volumes and you can maintain state there, and it's kind of a well-established pattern. But a lot of kind of infrastructure-focused solutions tend to overlook the needs of databases, whether it's third-party infrastructure backup solutions that, maybe don't interact with the backup infrastructure of a given data store, or just kind of treat everything equally. Your databases and your data stores are always going to be a little bit more challenging, and they're going to need special care. And they're critical because that's where your application data is. It's not, that fancy web page is nice, but if it doesn't have data to pull from your product catalog, you're not gonna be able to really service your customers. Beyond just talking about the infrastructure and plumbing that we associate with data stores and how we keep them in place, the pure challenges of having data in multiple places presents a major business challenge. So, understanding how to have this, how to work this, and how governance processes around where your data lives, what the single source of truth is, that can also be a challenge. And we see this data sprawl happen a little bit more with multi-cloud environments, because a lot of times one of the main reasons I see for multi-cloud is that a customer will want to use a best-in-class PaaS service. Maybe Google Cloud has a better machine learning offering than Microsoft Azure does, right? Just a basic example. That is something you can harness, but at the same time, you get data all over the place and you have to manage that. And we'll talk a little bit about that later in this session. So my main kind of goals here, what I wanted to talk about today after that little bit of an intro, are multi-cloud database management challenges. So it's not trivial to deploy things to the cloud, to multi-cloud. It may sound like it, and people may have good ideas and you may see stuff, but it's not really easy. You just have two different platforms, and even I shouldn't say even, probably the most important thing is having the skills within your team to perform management activities across those clouds. That's probably by far the biggest challenge, more than any technical challenges or cost challenges, getting networking to work and things like that. We'll talk about cross-tenant security and how to manage those solutions, because a lot of times when we talk about multi-cloud, we're talking about companies that are building software as a service solutions, and they need to think about higher levels of uptime than maybe a simple manufacturing company might need to think about. We'll also talk about some migration challenges that I find companies run into as they're migrating to the cloud. And then finally, we'll talk about data management and governance. So I think those are kind of the key tenets. And these are kind of diverse topics, because we're talking about a few things that are more like administration, and we're also talking about governance. And those are typically two different groups of people, but a lot of times, and I can speak to this because I've been either a database administrator or a database administrator adjacent for the 22 years of my career. Things like data governance, even though they shouldn't be the job of the DBA, sometimes, like in a smaller organization, you're the only person who can bring attention to those sorts of problems. So for those of you who are in those roles, you have my sympathy. It's really challenging. So no matter what sort of data structure or data store you use, almost every application has some kind of a data store, whether it be a relational database like the open source offerings like MySQL or Postgres, or a SQL Server or Oracle, or if you're using an object store like MongoDB, or a cloud service like Aurora or Cosmos DB, applications need a persistent data store. We have to do things like transactions and record them. A lot of people thought the relational database was going to die about 10 years ago with the advent of NoSQL solutions. Kind of the opposite happened. I think NoSQL solutions evolved to become a little bit more transactionally consistent in some places. But the principles of all these things are the same. You have a persistent data store where you record data that gets written. It's persisted, backed up, hopefully made highly available or not. And managing that data across systems requires specialized skills, data synchronization, and robust networking. So as we move into going from a single server hosting a database, which is, frankly, kind of a little bit of a business risk, because if it's a critical system and you only have one server, as soon as that server crashes or that operating system crashes or that database management system crashes, you suddenly have nothing. Your application is down. So most organizations that have business critical applications will try to move that database, whether it's a relational database or a NoSQL database, into a highly available design. In fact, most of the NoSQL databases that are built are kind of built with highly available concepts in mind. So you inherently implement a cluster of databases. However, as soon as you move that data out of a single system, you are now managing what we like to refer to as a distributed system, and everything gets a little bit harder. So you have to worry about things like time synchronization and conflict resolution. And actually, right before I was on this call, I was sending an email to someone on a distribution list I'm on who was having, high levels of latency and getting data replicated to a secondary copy of their database, and they were trying to understand why that would happen. So challenging is a word, and this is one advantage of like cloud services. Although, to be fair, the person I was just talking to about that latency problem was using a managed database service and was still having a latency problem. But it's a whole different set of skills. And one of the other things I like to tell DBAs in a modern cloud world, and I joke with one of our consultants about this because her background is strongly in business intelligence and less so in infrastructure. But in working with the cloud, she's developed a lot of network engineering skills, because a lot of times you're the one who's got to figure out the, because you're deploying these data services and you need to deploy them in a secure fashion. So it's not just that you have your data or database skills. You now need to understand how networking works, not just in the cloud, but more broadly, because a lot of the times, especially in a small organization, you might have like one network person, and maybe they're not super cloud focused. So you need to learn how those things work. And part of those implementation details, especially when you're going to implement services, building the network is kind of on the person building the services. So there are a lot of challenges there. So as you move into distributed systems with databases, networking suddenly becomes way more important. Likewise with cloud services. So remember, those are things you kind of need to understand. So I like to focus on the general task that a database administrator has. There's no typo on the slide. You'll notice I have backup and restores, and I didn't really emphasize restores enough. It's not quite bolded enough, but trust me, it's bolded there. Backups and restores, and backups and restores, and backups and restores. That is your number one job, to protect the company's data. Like we mentioned, the data is incredibly valuable. You don't have business operations without it. I mean, think about a bank. Anytime you transact with your bank, those transactions all get recorded in the database. That data needs to be highly available. If something bad happens, data corruption because of a disk failure, a server crashing, that data needs to be protected. Likewise, ransomware attacks, how do we protect against those? Backup and restore. And we'll kind of talk through that more specifically. But I know we always talk about backup, but backup's not enough. You need to be testing your restores. And that's one of the things that the cloud can provide us, right? It gives us, in the past, if you wanted to test or restore, you had to get another server or another virtual machine from your system administrator. And you had to get, especially if you had a larger database, you had to get, terabytes of disk space to potentially restore it. Now, with the elastic resources we have available in the cloud, and this can be a good example of how you can use hybrid cloud, even if you're on-prem, because you can extend those DR tests into the cloud without having to compromise your on-premises infrastructure. So if you're using an appliance on-prem and you don't have enough capacity to have a random copy for testing restores, you can easily get that in the cloud. So that's a really kind of a key benefit, is that elasticity in using resources only when you need them. Next is managing database security, and this takes on many folds, and we'll talk through it. But this includes, your basic RBAC permissions as to who can access what resources within a given database. Not giving system administrator to all of your developers, but it also includes things like, consulting with your development team about how to encrypt data and how to mask sensitive data as it may be visible. And even honestly, if you're a DBA or a system administrator, protecting yourself from viewing sensitive data. In an ideal world, even the DBA can't see sensitive data in a database, and that's tough to do. And there are certain aspects of this that are kind of key, but that is definitely something that's a big concern as to ransomware. So this takes on a few factors. Assisting with database performance, I kind of have this fourth, and I've kind of put these in. I kind of did order these. DBAs love to work on performance. If I can attest, speaking at conferences and stuff, if I'm ever talking about a performance tuning topic, that always draws the biggest audience by far. Honestly, as a DBA, it's probably one of the smaller parts of your job, not because of lack of importance or anything. It's just typically you're doing other things to keep the lights on. So you're worried about those backups and restores. You're worried about jobs not failing. You're worried about security problems. And you just don't get that much time to assist with performance issues until kind of the world is on fire and you're trying to solve some problems. That kind of falls into things like looking at query execution plans, understanding suboptimal database structures, adding the right indexes. Those are all things that are kind of the same whether you be in an on-prem world or a cloud world. Obviously, in the cloud, you have a little bit more visibility into costs, so there's a little bit more correlation there. And then finally, maintaining HANDR solutions. And this that aspect of being a DBA, I think, is a place where you see a lot of overlap with, say, network engineering and system administration, because when you start building clusters, maybe on Windows or Linux, or you start looking at cloud services to make things more highly available, you have to have a good understanding of both networking, servers, storage, all sorts of things to bring those solutions together. And that's the other reason why I kind of have this last on this slide is not all organizations are going to do those things. Let's face it, some organizations may be comfortable with some amount of downtime for a business application, and that's perfectly acceptable as long as that's understood. What's not acceptable is when your organization's like, we can only be down for 30 seconds a year, and then they give you a single physical server that's 12 years old and expect you to hit that SLA. That's the bad compromise, what you want to avoid. High levels of uptime are reachable for high levels of money. Low levels of uptime are reachable for low levels of money. Usually the happy medium for most applications is somewhere in the middle of those two things. The key kind of, honestly, the most important aspect of HADR that the DBA should play is that they should be communicating with their management and their management's management about what their uptime expectations are for their given infrastructure, and if the business is okay with that, or if the business needs to spend more money to build something cooler. And I know in my career, I have been guilty of building something cool for the sake of building something cool and to beef up my resume. So I will not cast the first stone here, but you should kind of build your systems and your application stacks to meet the needs of your business as you see fit, and not to build the latest cool thing as much as you want to. So backup. Backups are kind of fundamental, and I'm going to date myself, but I remember during like my first internship, it was when you could first take what we called hot backups of Oracle. And a hot backup, for those of you who are under my age, is just simply when you can take a backup of a database with the database being online. And I know that seems like really basic stuff, but back in the mid to early 90s, you had to take a database offline to take a backup. Not really practical in a 27.5.9 world, but there are a lot of key aspects to backup that go beyond just taking database backups. Understanding where you're storing your primary backups. One of the things I see a lot in on-prem world is that backups will be backed up to the same primary storage as the database is on. This gives us kind of a single point of failure. I know with modern object storage, it's really hard for an entire storage array or a cluster of hosts to fail. But I still don't really like having my only copy of my backups being on my primary storage that is the same storage that my data is on, right? Because if you lose that storage, you've then lost everything. Additionally, with ransomware and things like that, if you have your backups that are in a place that are directly accessible by your database servers, it suddenly becomes very easy for an attacker to kill your backups while they're killing your other stuff. So you need additional security measures around backup protection. Some of the backup vendors have solutions in that space. Cloud vendors have solutions in that space. A lot of what I see customers doing is maybe backing up to local disk storage and then copying that backup into an object store like Amazon's S3 or Azure Blob Storage. That gives you an additional layer of protection. So the other thing is also maybe separating security aspects, and this is kind of the term that comes to mind most frequently here is immutable. It's making your backups so that they can't be written over. One of the advantages that the cloud storage firms kind of have is they have the ability both to make your database, your objects in general, not just database backups, but any file that's stored there immutable, which can't be written over or updated. Also, beyond that, they have some additional security protections in place like soft delete and maybe separation of accounts that you can take advantage of so that you can effectively have a hidden second copy of your data. And that's going to protect you against any sort of ransomware attack, so that the typical lateral movement that happens in a ransomware attack where the attacker is going to go from server to server or host to host in your infrastructure, that's going to have something that's effectively offline that they can't easily get to. So you want to think about that. One of the things I have a few customers doing is they'll use the archive tier, whether it's Amazon Glacier or Azure's archive tier, which that storage is effectively offline. I know Azure uses tape, and so you don't have direct access to that storage. You have to request it to be remounted. So that just provides additional layers of data protection. Basically, you don't want your backups to be easily deleted or encrypted. By not you. We'll talk a little bit more about encryption later. And yeah, there are times you should probably encrypt your backups, but you don't want somebody else to do it for you and not give you the key. One of the things that's interesting about cloud is it makes it easy to have multiple locations for disaster recovery, even if your data lives on premises. This is kind of a key takeaway from yesterday's outage. You want your application to be able to work in multiple cloud regions, both with object storage, Amazon and Azure, and I'm sure Google, I don't know this for a fact about Google, but they have geo-replicated storage. So you'll write your maybe backup or any other file to a storage bucket, and then that file will get geo-replicated asynchronously to another cloud region, protecting you against a regional outage. One of the typically first entrees into cloud that we'll see for a lot of our customers is for them to start pushing backups into the cloud, just because there are so many data protection advantages you have in the cloud that can kind of prevent a single point of failure there. Finally, test your restores regularly. Like, I can't emphasize this enough. Just yesterday, and I mentioned this kind of in my column today, ironically, on the day there was an Amazon outage, I ran into a bug on a cloud database level, on a cloud database platform as a service offering, where my customer was doing a DR test and we couldn't see their backups. So that was kind of weird, and that had happened that day. And I followed up with the vendor, and the vendor acknowledged the problem, and we're working on a resolution. I'm not sure if the backups don't exist or they're just not visible. But had we not tested that, and remember, this is a managed PaaS service where we're not even the ones taking the backups, the cloud services. Had we not tested that yesterday, we might not have known this was a bug, and if we had to restore or we lost a region, we would have been kind of out of luck in terms of being able to get that database back online. So testing that process and you more broadly, you want to test disaster recovery on a somewhat regular basis. And that was what this was. It was part of a disaster recovery test because you don't know what's going to happen and you don't know what all the risks are. And I can't emphasize this enough. Your number one job as a data person is to ensure that your data is protected. And usually, if a backup gets completed successfully, you're going to be okay in terms of being able to restore it. But, 1 in 100 times, you can run into errors. Databases will back up corrupt pages and things like that. So have a good understanding around that. Next, let's talk about data security in a multi-cloud world. There are really two aspects of this. And the first I want to kind of talk about here is data security and how we manage data security. There are a few aspects to this. One of the more common data security requirements, and as I recall, it comes out of Sarbanes-Oxley for public companies, is that all data should be encrypted at rest. Encryption at rest is kind of useful. It's a little bit less useful in a cloud world, but what encryption at rest simply means is that you've encrypted your database files and typically backup files with a key. And so if somebody were to, say, steal the physical drive that your database files were on, they couldn't, or backups, or grab a backup, they couldn't open those files without a key. So you have to have that certificate. That certificate will open the file. Pretty easy to implement encryption at rest, especially in a cloud world, because in a cloud world, we have really trivial, flip a switch, your cloud vendor can manage your certificate for you. It's a little bit harder if you need to manage your own certificates, but in general, it's still pretty straightforward. The vendors have done a good job of letting you have that kind of thing. The downside to encryption at rest, it means nobody can read your backups unless they have their certificates, so you need a backup strategy for your certificates. That's another key thing, and that's a key part of testing. There's restores. The other bad thing about encryption at rest is it doesn't really do anything to protect your data from people who have access to it. If you have a disgruntled, and it's always a disgruntled, employee who wants to, download your entire customer list into a Excel spreadsheet and sell it to your competitors, there's nothing preventing them from doing that if they have access to the database. Obviously, you can have other control mechanisms like auditing in place, where you can identify who is the employee who did that, but encryption at rest does nothing to protect you against that. So what do we do to do that level of protection? Data encryption, and that means we're encrypting the data within your tables. And this has a couple of negative implications. So encrypting data makes it harder to index, which means you're going to have a harder time with your performance management. This also requires changes to your application, so it's typically kind of hard to implement after the fact. The other aspect of this is a lot of older encryption mechanisms don't allow or don't prevent a database administrator or a system administrator who has sysadmin access to the database being able to read the data. So a couple of the newer, the one I'm most familiar with here is Microsoft's Always Encrypted. The application itself is the only thing that holds the encryption key. So if the DBA is looking at the table, the DBA is just going to see the ciphertext of the encrypted data and not the actual values. Always Encrypted was an effort from Microsoft to make a low-code change required data encryption strategy. It's not super low change, but it still requires some level of changes. But it's better than nothing, and it is very secure in terms of in the fact that the DBA wouldn't be able to see the data almost ever. So that's kind of a good thing to roll with. The thing about data encryption that's so challenging is those application aspects. So you really need to be thinking about it from the start of when you build your application. It's not something that's easy to implement after you've done that. So data encryption is always a challenge. It kind of should fall more on your application developers, but let's face it, in reality, it's going to fall kind of onto you as a database administrator. Finally, basic database role-based access control. So this is controlling who has access to what tables and maybe even things like row-level security if you're in a multi-tenant database, who has access to what roles. Obviously, the kind of rules you want to apply are the principle of least privilege. Don't overgrant permissions, and then have a third party or someone else audit your permissions from time to time. This is because you don't want to overgrant things, which I find happens a lot. My worst story of this was auditing someone where I found that this was kind of a comedy of errors. There was a job that I found in the database that was something SS job, and I was like, oh man, I have to look and see what this does now that I've seen what this job name is. And sure enough, there was a table with 400,000 unencrypted social security numbers and all of the other personally identifiable information you would need to steal somebody's identity. Not only that, but through a combination of linked database servers, it turned out that domain users or anybody on their network could access this database. So therefore, anybody in their domain had full access to this 400,000 plus list of social security numbers without any sort of auditing. So having external reviews from time to time can be really helpful with that. In terms of cloud and how we think about this, control plane security is really important. And what do we mean by control plane? So the control plane's the portal or the console and the command line and the APIs as to how you interact with your cloud. And you may ask, why is that so important, and don't we have a cloud administrator for that? Yes, you do, and you should have a cloud team that manages that and ensures that that is secured. But at the same time, you want to ensure that your database resources are kind of locked down. I know, at least in the platform services I've worked on, anybody who has full control over the database resources can change who the administrators of the databases are. They can drop databases. They can change the local administrator password. So you want to really understand who can access those resources and who can create, update, or delete those resources. That's another aspect. One thing I always kind of want to protect against a little bit is an overzealous cloud administrator saying that there's an expensive resource and deleting it because it costs too much, and it turns out it was, say, a production database. And there are some additional cloud protections like locks that you can put into place to protect against that. The other thing you want to think about, and this is kind of a combination of application and database security, is you're going to have service principals in your cloud, and these are kind of the equivalent of service accounts in an on-prem world. And you want to ensure those are locked down and don't have too much access in case somebody hijacks an application from you. So back to database encryption. Like I said, encryption at rest is really easy in the cloud. And for the most part, it's really easy on premises. A lot of organizations just handle it at the storage layer now. So you don't even have to worry about it from a database perspective, but encrypting the database files is pretty trivial. Like I mentioned, it doesn't secure the data in your database. Encrypting that data within the database is going to provide a lot more security, orders of magnitude more security. You can get, if I have the data encrypted in the database, I don't really even care if an attacker gets that data because it's encrypted and it's useless to them without the key. But like anything else, anything that requires application changes are going to be much harder to implement. You're going to have developers actually touch code and change code in order to make those work. They may even have to change the versions of the client software they're using. So this is not something that's easily done. Ideally, you catch this when you're building a new application and you get that data encrypted as it goes into the application and you've designed for it, rather than trying to do it after the fact, because trying to do it after the fact is always really difficult. I remember we had this really small engagement with a small company who was trying to implement database encryption, basically so one person couldn't see the other person's salary. which I found amusing. And even in that kind of small scale, it was pretty challenging to get it implemented because they ran into some limitations around doing math on encrypted values. Things have improved since then, but just be aware of those challenges. The main difference you'll see in multi-cloud is understanding where you store your certificates and keys. One of the kind of cool things in the cloud, good things, bad things, you do have places that you can secure those keys, especially talking after yesterday's meltdown at Amazon. You want to understand where those single points of failure are, though, because I know, for example, there was an outage in January of 2019, came up yesterday when we were doing some research on cloud outages, where Microsoft's service that held certificates was down. And because that was down, customers who had brought their own certificates to Azure SQL Database, Microsoft's data service, lost data because the default behavior of the cloud was to stop the database in the event that the certificate wasn't there. So interesting stuff. You want to be aware of that and understand how you secure those things and what that high availability mechanism is, or just simply what the failure mechanism is if those keys or certificates are not accessible. So control plane security. The easiest way I like to think about this is think about putting your data center door on the internet. You don't want to do that without any other sorts of protections. Another way to think of it is if you're a virtualization person, and it's kind of like putting your VMware vCenter on the internet. So securing access to those resources is a key part of cloud security. One of the things you can do is enforce network and security controls that are widely and easily deployed. You can not allow anybody to connect to your cloud console without being attached to your VPN, and even then, you can still make them multi-factor authenticate to ensure that it's them and you have those resources in place. So this typically isn't the job of a data engineer, but it's definitely the job of a cloud engineer. So if you're accessing your cloud control plane just with a login and a password, lock that down. Like, it's not that hard. Typically, I know on the Azure side, at least, administrators get free MFA without even having to upgrade their accounts. So make sure you have that in place. Once authenticate has been authorized, so once you've gotten past your network and security in your network and login controls, you want to ensure that you don't have crazy amounts of access in your subscriptions, right? It's fine. You want to empower people, and one of the benefits about the cloud is that things are flexible. But just like in your databases, you want to use the principle of least privileges. Don't give any more permissions than people need. Limit who has access, especially to critical resources, and understand delegation and how you can use roles and groups to give very specific sets of permissions. Everything in all the clouds is effectively a graph API, and you're granting specific permissions to those APIs. There's no need to overgrant things. Sometimes it's easier. I'll give you an example of this. I had a customer who wanted to give, they had a customer, so a downstream customer, that needed to be able to create new firewall roles for their resource. However, the problem I ran into was the GUI solution that granted firewall rules required way more privilege than just being able to grant firewall rules. So I had to talk to their customer and ensure that the customer who was implementing the firewall changes was okay with using a command line tool, and he was. And then I was able to get away with only giving him just the permission to change that firewall. So having good understanding of what the security looks like can really limit your risk profile. And remember, your databases are their own resources in the cloud, and they can be deleted, dropped. So securing those is really kind of critical to maintaining good data integrity and protection. Another consideration is network security for databases. So I just talked about database firewalls, and especially when you move into PaaS services that may be by default publicly exposed to the internet or storage services, you want to understand, and this is where having some of those network engineering skills comes into play. Understand where you can access those from. You probably shouldn't be able to access sensitive data from anywhere on the internet. It should probably be locked down. A lot of those same services have the ability to be locked down to only private network traffic. So it may be important to have a discussion with your cloud vendor about this to understand the network impact of your services and what they look like in terms of how those networks work. Another key aspect, even your virtual machines can have public IP addresses. It pains me every time I build a VM in Azure that the default setting is for a VM to have a public IP address, and if it's Windows, to be open on port 3389, which is RDP. SQL Server even gives me the option of opening SQL Server to the internet. These are things you should pretty much never do in a production situation. I do 3389 a lot because I'm just doing quick demos of VMs, but just to give you an idea of how bad this is, Denny Cherry, who I work with, and I were bored one afternoon at a client's office, and we decided to see how quickly we could get a SQL Server that we put on the internet hacked. And so we exposed 1433, which is SQL Server's default port, to the internet, used a system password. SQL Server uses a well-known account called SA. We set the password to password, and we enabled trace on the server, and then we just sat back and watched. And within 20 minutes, both of our servers were completely hacked. We obviously didn't have any data on them. They weren't hooked up to anything else, and we quickly dropped them. But that just goes to show you how insecure that is. Even if you have a secure password, if you put 1433 on the internet and you look at your error logs, they will be chock full of people trying to attack your server. Likewise, if you put port 22 for secure shell or 3389. If you are in a cloud environment, take advantage of the security advisors that are in the cloud. I think both Amazon, Azure, and Google all do a pretty good job of kind of analyzing your environment against best practices. Typically, if you're in an on-prem world, it's going to be a little bit harder to have exposed resources. You can allocate public IP addresses, of course, but it's a little bit harder to just accidentally do that the way you can in the cloud. So to me, this is definitely something that's a little bit more of a cloud, because it's a lot easier to give stuff public IPs there. Database performance. So one of the things that's kind of neat about the cloud is database performance issues are going to exist there just on-prem. In fact, a lot of times your storage is going to tend to have a little bit higher latency than in an on-prem world. I'm not talking like orders of magnitude. I was looking at a really busy customer system the other day, and I was seeing disk latencies in the 5 to 10 millisecond range. Granted, they have really big VMs, and there's a lot of storage, and there's a lot of storage bandwidth there. But if you're in an on-prem world, have really fast direct attach or fiber attached solid state or NVMe storage, and you're used to seeing sub-millisecond latency, you're probably not going to see that in the cloud. So that can kind of exacerbate some of the performance problems you may see in an on-prem world. Effectively, you still need to tune things like indexes, bad queries. You need to look at execution plans. This isn't really going to change. What may change, though, is you may have some additional services available if you're using platform as a service offerings. I know Microsoft, for example, includes some extra stuff in Azure SQL Database and MySQL and Postgres that allows you to do better query tracking. HADR, and this is my first bullet point here, is kind of ironic after yesterday. Your cloud workloads are typically held to a higher SLA than on-premises until the cloud goes down. For the most part, I think looking at the uptime my customers have, I would still say this is true. Typically when outages happen, they're bad and they're long, but they're infrequent. However, computers still break and software still fails. So you either need to have a tolerance for failure if you're going to build things in a singular manner, or you need to spend more money in engineering effort to build things in a more distributed manner so you can survive, hardware and software outages. And having a good understanding of what the failure profile of your cloud is going to look like, or even your on-premises environment is going to look like, I think these are the kind of two key aspects there. And while multi-cloud is popular in a lot of ways, I think planning high availability and disaster recovery across clouds is very hard. It's not as easy as as that rainbow in that little image there. There's a lot of plumbing that needs to take place. So data integrity, where does your data live? If you're in a multi-cloud world, which cloud do you have your point of sale data in? Where's your single source of truth for this sort of data? These are all kind of challenges that you need to think about. And honestly, this goes beyond what an administrator does and leads us in the kind of key topic I always like to come back to around governance. And governance is never the most exciting topic. It's boring and it's hard to fund. Sexy new applications that are going to lead to more sales are always way more exciting. But whether it's security or data or business intelligence, having good governance around your data is always going to increase your data quality. It's going to let you make better decisions, both business decisions and security decisions. Like if you know where your data is and you know what data is where, you can more easily secure it. And this isn't just the job of the database administrator or the system administrator. It takes a team, and typically this team has to be kind of integrated with the business. So this is one of those places where IT and the business organization overlap. And honestly, data governance, in my opinion, is more of the job of the business because they understand the business data. And IT's job is to kind of implement that governance strategy. And especially in a cloud world, having data kind of all over the place and not really understanding where that single source of truth is can happen very easily. And just to close out before we take some questions, cloud is not particularly hard. It's just very different from your on-prem world. So it's a lot of changes to what you're doing. So you're going to face challenges around security. You're going to face challenges around storage, just how different things work and what things cost. Multi-cloud is way more than 2 times as hard as single cloud. Just getting the people in place to support a multi-cloud deployment is really challenging. Back up and restore your data early and often. Don't just back it up, restore it. Make sure those restores work. Make sure you're having successful restores, and ensure that if the lights go out, you can still maybe restore a database. And then governance is the key to avoiding data sprawl. So good governance will let you know where all your data is and have things like catalogs and things like that that will allow you to better manage your data. And with that, I think we can go into Q&A. Do we have any questions?
Yeah, Joey, thank you very much. I also want to thank again our sponsor, Hyperconverged Infrastructure Pioneer Nutanix. Okay, we'll get some questions for our attendees. Remember, folks, you can type your questions into the Q&A box at any time. We'll do our best to get to all of them. Okay, Yuri wants some clarification. The company that relied on Microsoft managing their certificates, did they lose the access to their database until things were restored and restarted, or was there really a loss of data?
So they were able to restore the databases. There was a small amount of transient data loss. So without going into too much detail, it is public. So I'm not talking out of turn here. They effectively lost the transactions at the very end. And I can find the link to that article and post it so that everybody can see it because I looked it up yesterday. But they lost transactions at the end. But their data was protected because they had backups.
Okay, we have another question here. What are the reasons organizations go multi-cloud?
There are a number of reasons organizations go multi-cloud. I think one of the more common ones I've been seeing lately is acquisition. They'll acquire an organization, and they'll have multiple data in multiple clouds. I think that's a pretty common one. Another one is choosing best of breed products. In large organizations, it's just kind of natural sprawl that happens because there's not necessarily a central governance org. Or you have, corporate VPs who are powerful enough to be able to say, hey, I'm just going to allocate 50 grand on my corporate card a month to a specific project, and I want to do it on this cloud service. That's something else I've seen happen. The least common of those is the planned, We want a high availability disaster recovery environment that spans clouds, that is, carefully thought out and managed.
Okay. Here's one. What are the main challenges of configuring a data store across public clouds?
I think the biggest thing is networking and honestly having the same services. You're kind of limiting when you're going across cloud. One of the things you're kind of doing is you're limiting yourself to either infrastructure as a service, so you're either building and maintaining your own virtual machines, or maybe you can do it also with Kubernetes in a similar fashion, where you can have a distributed Kubernetes across clouds. But you're not taking advantage of any of the platform as a service offerings that lead to better automation and kind of reduce your overhead. It becomes kind of a manual effort.
Okay. Here's one. What is the best approach to encrypting data within a database?
You're going to want to consult your database vendor for this one. Like I mentioned, Microsoft Always Encrypted. That's the one I'm most familiar with. Oracle has some solutions as well. I think their cost options, which is not uncommon for Oracle, sadly. But the best approach is really first identify what data you need to encrypt. You never want to encrypt. There's a high cost to encrypting data in terms of performance. So you never want to encrypt like your entire database. You want to encrypt the specific that have sensitive data that are dangerous if they get into somebody else's hands or are leaked. Ideally, you want the keys to be stored external to the database. That isn't always possible, but if you can manage that, that's a good approach. So it's kind of an understanding what the options are in the database or data store you're working in, and then only encrypting the data you really need to encrypt.
Gotcha. Okay, we have a question here from Deval, but I think it needs to be clarified. The question is, can you help more with what our security should be in a multi-cloud environment? Maybe, Deval, be more specific?
Yeah, I mean, the main thing I can say about that, just to kind of answer some stuff,
sure,
is
awesome.
The challenge of that is control plane, right? So if you're working with, say, AWS and Azure, you're gonna be you have two entirely different security paradigms that you need to manage, right? And it's not that they're completely different. A lot of the concepts are the same, but a lot of the nuanced stuff between different clouds is different. So you can't take the same set of roles and users and groups that you had in Azure and then apply them to AWS. So you're going to have to create 2 times the number of security policies and things like that.
Okay, it looks like that's all the questions we have right now. And waiting just a second. Okay, so no clarification. Looks like that's all the questions we have time for anyway. Many thanks to Joey D'Antoni for a great session, and to our sponsor, Nutanix, for making it possible. We are going to take a short break, but Mr. D'Antoni will be returning at the top of the hour for our second session, Hybrid and Multi-Cloud Data and Database Best Practices, which will be moderated by my colleague, David Rammel, who leads the editorial at Virtualization and Cloud Review. Now would be a great time to check out those extra resources on your console provided by Nutanix. And remember, during today's third section, we will be giving away a Surface Pro 8, but you must be present to win, so stay tuned. Back in a few.
Okay, welcome back, everyone. Thank you for being here. Thank you to our speakers, my fellow moderators, and of course our sponsor, Nutanix, for underwriting this summit and allowing us to bring you this great content. I'm David Rammel, editor of Virtualization and Cloud Review, here to moderate the second session of our summit called Hybrid and Multi-Cloud Data and Database Best Practices. I'd like to welcome back Joey D'Antoni, Principal Consultant at Denny Cherry and Associates Consulting. For those of you who didn't attend the previous session with Joey, he is recognized as a VMware vExpert and Microsoft Data Platform MVP, and he has over 20 years of experience working in both Fortune 500 and smaller firms. He has worked extensively on database platforms and cloud technologies and has specific expertise in performance tuning, infrastructure, and disaster recovery. Joey, it's great to have you back. Please take it away.
Thanks, David, and welcome everyone to the session. Hybrid and multi-cloud data and database best practices. This is kind of a good one. It was kind of fun to put these together and just talk about different things and different approaches to cloud and how data works there. And I wanted to bring up database best practices. If you're new to managing databases, some of this may be not over your head, but enlightening, and I wanted to keep it at a good level. If you're new to the cloud or just there, we'll talk about some of the decision points you need to make as you move into the cloud. It can be confusing. There are so many offerings. I mean, I can tell you just from the last time, well, and this is now 2 years ago, but I was working the booth at Microsoft Ignite for SQL Server, and I had so many people come to the booth and ask for explanations of like between the different cloud offerings and what their decision tree should be on how they choose which cloud service to use. And I wanted to kind of talk through some of those options and talk through what the differences are and talk about what you need to know and how things are priced and the things you're going to see as you move into the cloud. And data is the backbone of your organization, and having good understanding around that is really important. So let's dive in. So I kind of broke this down into 4 sections. I want you to understand what the cloud data service options you have are. A lot of what you're going to hear in vendor marketing is all about the really cool platform as a service offerings they have. And I'll be the first to tell you, there are a lot of benefits to using platform as a service offerings. But I will also tell you, if you're using them, you're probably going to be using them for the lifespan of your application. They're hard to move out of. Not that it's easy to move out of infrastructure as a service, but it's easier to move out of those. But one of the things you want to understand too in choosing those services is, how well the cloud vendor you're working with supports that service. Is it really like a first-class service, or is it something that is kind of a redheaded stepchild that doesn't get as many updates or doesn't see as much love compared to some of the other services? Those are hard decisions to make, and you need to have some real good understanding there. Next, we'll talk about monitoring your environment and how this is a little bit different in the cloud, and then again, how it's not. We'll also talk about what you need to do to keep the lights on in your environment, so how you can maintain things. This whole keeping the lights thing on is kind of really a big one to talk to. If you're in my earlier session, I mentioned I wrote a column this morning on yesterday's Amazon outage. It is now up on redmondmag.com, so if you want to read that after this talk, I talk about a lot of the things that you have to consider, and a lot of the things I'd like to see cloud vendors do better, and just more information sharing. So you want to understand how things are going to fail, and if they fail, how you respond to that, and how you can protect against those failures. And then finally, protecting your data, so security and backups. And we talked through that a little bit earlier, but we'll talk about it some more and with some different aspects in this session. So 2 of the common terms, if you're new to cloud, maybe if you're pretty experienced with cloud, you've heard these a lot, are infrastructure as a service and platform as a service. So infrastructure as a service is pretty much the same across providers in that we have VMs, we have storage, and typically when I'm talking about infrastructure as a service storage, I'm talking about the kind of storage that gets presented to virtual machines more than the object storage that you're accessing programmatically. And I really like to think of infrastructure as a service offerings as something that is almost 100% analogous to your on-premise virtual machines or even physical servers. They're kind of a one-for-one. This is typically most organizations as they enter the cloud, especially if they're a mature organization with a lot of IT resources. this is going to be how they're going to go into the cloud, having a one-to-one kind of match for resource types. There's nothing wrong with that, other than it's kind of an expensive way to do it, and you're not really gaining as much productivity. You're still responsible for patching. You're still responsible for all the networking stuff, and to an extent, networking is plumbing that needs to happen anyway. So you need to have your virtual network solutions built, even if you're using a lot of platform as a service offerings. But those are kind of the basics and the easiest way to migrate. And even then, it's not trivial to migrate. If you've ever migrated a data center just from one data center to another, you know that's not easy. So migrating from one paradigm to another on-premises data center to cloud, even if the building blocks are really similar, it's not easy. The storage is different. The way you do networking can be different. So just because people make light of lift and shift and say it's easy and trivial, it's not. There's a lot of work into doing that. But it can be easier, mainly because you don't really have to change your applications. If your application runs fine in an on-prem VM, if you can get a similarly configured cloud VM, it's run almost exactly the same if you have everything else in place. And that's why so many mature organizations are drawn to infrastructure as a service solutions. Platform as a service solutions, and I'm going to talk specifically to databases here, but I'll cover kind of a broad array of databases. These are database as a service offerings or data lake as a service offerings. And the main ones I have here are Azure SQL Database and Managed Instance, which is Microsoft's Azure offering. They also have a MySQL offering and a Postgres offering that run on the same platform. Microsoft also has Cosmos DB, which is kind of a family of NoSQL databases that all run on a common platform. Amazon has Aurora, which is a part of its MySQL and Postgres and I think a couple of other databases. They also have a service called RDS that's really similar to what Azure has and analysis with Azure SQL Managed Instance that can run SQL Server, it can run Oracle, it can run MySQL. It's kind of a managed IaaS offering. And typically, like what these solutions will do for you is they'll ensure you have high availability. They'll ensure you have backups in place. You typically don't have to worry about patching anything. That's another kind of nice aspect. The operating systems and the database software gets patched for you, hopefully in a pretty online fashion. That is the most common way. The other thing to think about here too is you also have services like data lakes that are available where you can just store data in cheap storage like object-based storage, S3 or Azure Blob Storage or Google Object Storage. And then you can separate your compute from that data. So a lot of cloud data warehousing services like Redshift or Azure Synapse Analytics can point at that data and just ingest it as needed and do what you need to do. So there are a lot of kind of neat offerings there in the cloud, and you definitely get more, I'll say, value add out of platform as a service offerings than you will out of infrastructure as a service offerings. I'll talk about when to choose those in a second because I think there's definitely some nuance. It's not as simple as like modern versus new versus old. I think that depending on how mature your applications are and things like that or where you're going to make those decision points. That being said, there are still some infrastructure aspects to those services. You need to think about like networking and storage, especially kind of on the networking side, because the cloud service, these platform as a service offerings, they can be locked into private networking. And understanding how all that works can be a little bit of a challenge. So like I mentioned earlier, networking skills are really important in these offerings. So when should you choose IaaS? The biggest answer I have is when you need to seamlessly move existing workloads to the cloud with minimal change. Tell you about a project I'm working on right now. The customer is moving. They have to be out of their data center by February or they're going to be tied into another contract. So they want to get moved as quickly as possible. And they're actually not just using IaaS. They're using a managed database service, but I'll talk a little bit more about that on the next slide. But everything else that's a VM is getting moved to the cloud as a VM. All their web apps that could maybe be running in a web app as a service, they're using VMs for because they just want to get it moved. This is the most common approach, and honestly, what we've seen with a lot of our customers is this will be their initial migration, but as they build new services, they'll choose PaaS services that are more modern and flexible after they do it. When we come specifically to databases, if you need to have a very specific version or feature of your database software, this can be a reason to choose IaaS. An example of this, and sorry, I do a lot of work with Microsoft, so I default to Microsoft examples. I'm sure there are other examples in other databases. SQL Server has a feature called File Stream that writes files to the operating system. This feature isn't available in any of the platforms as a service offerings because Microsoft would have to effectively completely redesign it because there's no access to the host file system from the platform as a service offerings, and it's not commonly used, so they haven't done it. So if you need a feature like that, or maybe you need to be on an older, unsupported version of your database software, this can be a common thing too. That's just not available in a platform as a service offering. You can stay on that. We have another common one is, your database is for a piece of third-party software, and that third-party vendor doesn't support using anything other than version X of Oracle and version Y of Linux. That's another example. If you want to manually handle your operating system or relational database management system patching, high availability in DR or backups, one of the things that you may run into with IaaS is that the needs of PaaS just doesn't meet your needs. Like there's VMs available in both clouds now that have like 24 terabytes of RAM. I have a customer that's got databases running on a server that's got 1.7 terabytes of RAM. Those aren't easily available in platform as a service offerings, but they are in a VMs. A lot of times you may want to have some special needs and you have a needy application. One of the other things you may note, and I want to emphasize this point because I think it's a point of clarity that is important. A lot of times you may price out an infrastructure as a service solution and it may seem cheaper than the functionally equivalent platform as a service offering. Remember, nearly always there's high availability built into your platform as a service offerings, and there are backups. So you are paying a little bit of a premium to support those. You're paying for backup storage. Multiple copies of your data or compute are going to be present there. That's part of the equation. And one of the benefits to PaaS is all that stuff is handled for you, but you do pay for it. So when should you choose PaaS? If you have new applications that don't have legacy dependencies, if you're building a new app and all your data is going to be in the cloud, to me it doesn't make hardly any sense to roll out a full version of a software or a database software and run it in a VM. Use a cloud database. It's just a lot easier. You don't have to worry about installing anything. You can get up and started in minutes in terms of coding your application. I want you to put some thought into that database, though, and how it's designed. I'll talk a little bit more about that later because you want to think about how things are going to scale early in the life cycle of your application, even if you don't think you're going to need that scale. If you don't have a full-time DBA, one of the things I mentioned that's so important is backups. We can't talk about that enough. One of the beautiful things about database services is backups are managed for you. You have point-in-time recovery without having to touch a single button or even check a box in the service. I think that's a real value add for organizations that maybe are new startups and you don't have anybody who's got a great deal of database experience. You also don't have to worry about staying on top of the latest patches. Your databases just get patched for you. And just broadly lower management overhead. I think in the data, unlike some of the maybe application-centric PaaS services, I don't think you gain a great deal of flexibility per se with going to a PaaS service, but I'll give you a real simple example. With Azure SQL database, if you want to add a read replica in a different region, maybe to be closer to your customers so that there's better performance in a customer-facing application, it's effectively 3 clicks to do that. If you wanted to do that in VMs, you had to build a VM, you had to build a cluster, you had to install load balancers. All that stuff just gets done for you in the PaaS service, and it's a lot easier to do a fairly complex task. So just keep that in mind when you're talking about these things. So does PaaS end the DBA profession? As I mentioned earlier, I've been a DBA for most of my career, and I have to say emphatically that no, it absolutely does not. There's still plenty of tasks. Performance tuning becomes a lot bigger thing as we move into the cloud because there's a bill now, and there's a lot more. It's one of the things that I found kind of really interesting about cloud computing. There's a lot more. The IT organization pays way more attention to the cloud bill than they ever did the sum of all the other bills they had when they were running in an on-prem data center. And I think it's because it's a single bill and it's kind of a big number. It incorporates everything. So if you can reduce load on a database server by making queries more efficient and you can reduce that cost, that's definitely a thing. Just managing data and understanding where data lives and getting data moved around is another thing. And then understanding the platform as a service surface area. Like I mentioned, there's way more visibility on this performance stuff because they're tied to billing. And you begin to understand how important reducing the bill is. I think the other kind of psychological aspect of that is all the IT management sees that same single bill. In the past, and in the olden days when you had a storage team, a network team, and a server team, and maybe a database team, all the bills in the IT organization were kind of spread out across multiple organizations. So nobody really ever saw, except maybe the senior IT management, saw that single big bill. Definitely a lot of psychological aspects of this, but it's definitely something I notice with my cloud clients. So one of the things you want to understand is choosing the right data paths. So if you're going to choose a platform as a service offering, you want to think carefully about what it is. There are some that are more infrastructure focused, and those are platform as a service offerings that are more designed to easily allow you to move an on-premises database into a platform as a service offering with minimal change. Some examples of that are like Azure Managed Instance or SQL Server. Amazon RDS is very similar to that. It's very much a server construct. And those can be really good for if you have an existing application that you want to move into a managed service, that will support it for you. So that can be a good offering. The other thing you want to think about is, do you even want to use a relational database? Or if you're building a new application, do you maybe want to use multiple databases or data stores, I should say, for your given application? You know, maybe you have a small JSON database for your product catalog because having flexible schema there is really nice. Maybe you have a key value store like Redis that's going to act as a cache so your database isn't getting hit as hard. When you're dealing with these PaaS services and you can roll them out very granularly and small, having multiple data stores for applications suddenly makes a lot more sense than when you have the whole overhead of having to deploy multiple VMs and maintain multiple operating systems. You're just deploying a few more services, and this can make it easy for you to scale your application. Each provider has multiple commercial and open source database services available. One of the things I almost always tell any of my customers is if you're deploying MySQL or Postgres, deploy it on the cloud. Don't bother with trying to do it yourself. The main reason why I say that is because I find it's really, really difficult to use the high availability and disaster recovery options around those databases, especially if you're not using one of the commercially packaged MySQL or Postgres. If you're trying to build your own high availability model out of open source components, it can quickly go down a rabbit hole, and I've been through this with a couple of customers now. If you're in the cloud, you're just highly available by default. And that's definitely a wonderful thing. The other thing to think about is your application's needs and what your developers are comfortable with. If you're working with a team of developers that have exclusively worked on SQL or relational databases for a long time. It can be hard to get them into a NoSQL paradigm where they have many databases in play. But at the same time, if you have newer developers who maybe haven't worked with a relational database, maybe they're more comfortable with using a JSON database. And this kind of goes a little bit beyond just your choices and what the broader architecture of your application is going to look like. But it's something that's really important. I remember reading this column like 10 years ago that I thought was pretty horrible. It was like, why Uber is going to fail because they chose the wrong data platform, which the author was terribly wrong, of course, but it is something that is kind of critical to your application. The other thing you always want to think about, even at the beginning of any application, is how you're going to scale your data tier. Generally speaking, in most cloud infrastructures, the most expensive piece of componentry is going to be your database server or your database service, or it's always kind of the biggest. It needs the most performance resources. There are some exceptions to this, but it's pretty common that that's the case. And you want to think about how to scale, because in a lot of cases, if you can scale out a bunch of small database services, you're going to get way better performance than having one, or at least cost to performance ratio, than having one really big database server. And in the cloud world, you can only go so big. And acknowledging the fact that so big is really big now, because there's a cloud in both Amazon and Azure. You can get a 416 CPU VM that has 24 terabytes of RAM. Said that's going to cost you all the money a month, pretty much. So having a bunch of small databases, like sharding data across small database nodes, can get you a lot more throughput. And there are some pretty good designs for this in Postgres and in MySQL, and even in SQL Server. There are some toolkits that you can use that will allow you to kind of horizontally scale data and partition it across multiple databases to allow you to run smaller databases per team. So that's something you want to be aware of and think about as you're building new applications, how that scale model is going to work, because it's really difficult for the fact to build a scale model. So having an architect or development team that's got good vision of where their app can be is really important at the beginning of the process, because once you kind of get into that model, see Uber failing because they chose the wrong data source, it's really hard to get out of it. So just to kind of switch topics into monitoring now, cloud providers do offer resource monitoring for your cloud, and in some cases for your on-prem or multi-cloud solutions. Typically, especially if you're working with VMs, these are going to come in the form of an agent that's installed in the VM that's going to send metrics back to the cloud control plane. Also, to a certain extent, the cloud vendor is going to capture metrics at what I like to call the hypervisor level. Hypervisor is the term we use from virtualization software like VMware and Nutanix. That's capturing things like CPU usage, the number of disk writes and reads, memory utilization. These are all things that can be observed without actually being inside of the compute resource, whether it's a PaaS service or a VM or running. So they can report that stuff to you without even having to have an agent. So they do have those offerings in place. They do charge for those, like you get some baseline monitoring, typically free in your environment, which is typically those hypervisor metrics. But if you're going to want to use your cloud's tools to do additional monitoring, there may be some charges to that. And typically those are going to be when you're diving deeper and capturing more metrics. And these are usually billed on like kind of a per metric basis. And these aren't anything that's really expensive. Where it gets really expensive is when you have 1,000 VMs or 1,000 cloud services and you're monitoring 12 different things in each of them. That's when that starts to become a problem. Third-party monitoring tools will work, minor typo there, fine in your cloud model. Most of the third-party vendors I've worked with, and I've worked with a lot of them, have built in place cloud solutions. This will definitely always work in an IaaS model, because really your VM in a cloud is no different from your VM on-prem, as long as the monitoring tool can talk to those solutions. you're going to be fine in terms of how that works. But you do want to understand, and this is where it's important to talk to your vendors, if they support PaaS services, what their support for PaaS services looks like. Because if you're using those PaaS services, the native monitoring is obviously going to work. But if you want to have maybe a single dashboard, your cloud solution or your monitoring solution would have to be able to talk to those services. So understanding how all that stuff works together may mean you need to talk to your monitoring vendors about what they offer. In general, I will say the first-party solutions in the cloud are really nice. They typically don't provide the same level of detail that maybe a third-party specialist database monitoring tool might provide. So understanding where that cutover point is pretty important. Centralizing your alerting is a challenge for multi-cloud if you're in a multi-cloud environment. And this is one of the places where multi-cloud gets really, really hard really, really quickly. Which cloud do you make the primary for your alerting? And if you're using a multi-cloud environment and you're using the native monitoring in each cloud, you're going to have two different sets of monitoring tools. And understanding how that can work in a multi-cloud environment is something you really want to think about. That's not a trivial thing to implement. Job scheduling, something that sounds kind of easy or basic, suddenly isn't. Even in a single cloud environment, this can be challenging. So understanding how you will run things in your cloud. The most common example I run to with this is none of the SQL offerings, whether they be SQL Server, MySQL, or Postgres in Azure, have schedulers built in. So if you install SQL Server on-prem, you get what's known as a SQL agent, which acts as a job scheduler, and you can easily run tasks, whether they be your backups or whether they be business logic tasks that are going to update data based on change feeds and things like that. That just doesn't exist in SQL Azure or the MySQL services. So you have to use other services. And the most common, Azure offers you a few options, as does Amazon. Azure has automation, logic apps, and functions that can be triggered by various things, or they can be on a schedule to run. But they're broadly different from what you've done traditionally on-prem. So you may have to acquire additional code and skills to implement these things. These can typically be Python, PowerShell, or Bash, but it's something that you need to be aware of. That's likely going to be a pretty significant difference as you move into a cloud. And if you're in a multi-cloud scenario, it's going to be twice as hard because you need to figure out how to run jobs in both clouds. And typically, if you're going to go multi-cloud, you're going to want to maintain your own job scheduler, which is going to be maybe in the form of a VM that just centralizes your job management, maybe using an enterprise job scheduler. And that VM can have the ability to talk in both clouds. So this is kind of a thing that commonly gets overlooked, but it is something that I find pretty challenging. And especially for data pros, maybe having those Python and PowerShell or Bash skills isn't necessarily a skill that they have. They mostly work in SQL, in writing SQL queries. So having to pick up additional language skills isn't something that's trivial. And then things like understanding how those services work, understanding how the monitoring and those services work. Anytime you start to layer in additional services, even the ones that are easy to implement, like Logic Apps is a great example of that. It's point and click, there's a drag and drop. It's a low-code solution. You don't have to write much code. But just understanding all the mechanisms around how to trigger things, how to monitor those job executions, those are all things that are really challenging, and you need to understand them. And another aspect to think about as you move into a cloud world. So security, and some of these aspects are kind of easier, I think. So a lot of the challenging security things you have in on-prem become easier. Multi-factor authentication is so much easier to implement in the cloud world. Like having multi-factor access to databases is something that's really difficult to implement. Cloud, it's really easy. It's just kind of built into the platform. Encrypting data at rest, we talked about this in the last session. In the cloud world, if you build a platform as a service database, I think almost all of them encrypt all the data at rest by default now. You don't even have to do anything. You can bring your own certificate for that, but you don't have to. You can let the cloud provider manage those. You don't, in the case of cloud provider managed certificates, you don't have to worry about ever losing a certificate or not having a backup of the certificate and not being able to access the data. From that aspect, cloud security, implementing robust security controls is definitely a little bit more easy in the cloud than it is on-prem. One of the other things that's cool is key vaults. And there's a specific feature called Key Vault in Azure. You can implement HashiCorp Vault, which is a nice feature. Amazon has a similar vault feature that secures things like certificates and secrets. And this helps all manner of things. If you're using encryption, a lot of times you can hook into using those vaults with the software that's encrypting your data. Even if you're coding small applications to do scripts, you don't have to worry about hard coding a password. You can just go to the vault and grab that password securely. And that makes a lot of things easier, because one of the most challenging things is always how to connect securely to things without hard coding passwords and scripts. Key vaults and also things like service principals make this a lot easier. So those jobs you're running, you can define a principal for maybe, say, your automation account or your logic app, and that automation account will then connect to your data stores as itself, and you can grant it the specific permissions it needs to do what it needs to do. You also have more options for how to secure your data resources. You have one of the cool things about running in a platform as a service model is you're going to be on the latest release of the software typically, or at least a fairly new release, which means you can take advantage of the latest features, whether they be open source or commercial, around things like data encryption, data masking, more granular security rules. That being said, all the fundamental rules still apply. We talked about limiting access in the last session, and it's important to have periodic audits of your data and your data structures to make sure that not everybody can see all of the data. You have good security controls in place, like row-level security, any of those things that prevent users from being able to see all of the data unchecked. One of the things I really like about the cloud database services is most of them will have auditing capability, and the auditing kind of runs in a separate compute space from your primary server, so you can audit heavily and not impact your workload like you would typically in an on-prem environment where you might have some I/O contention with that. Just the other day, and this wasn't a real security thing, but we had a customer who said that they were having a firewall error at one of our customer databases, and we were able to scan and see that they were getting in and they were running successful queries. So having those robust audits in place, that does cost money, by the way, so just keep that in mind. But it allows you to make more intelligent decisions. So optimizing your environment. This is always a non-trivial, simple word. You'll see a lot of this from maybe tools vendors who will promise you the easy way to identify the problems in your environment. It's never, ever that simple. I will always say that one of the things I'll always say is there's almost in every, and I've consulted at a lot of companies, I've worked in a lot of companies, there's almost always like a 90-10 problem in companies' application stacks. There's always one application that can like 90% of the both money and compute resources. When I worked at Comcast, we had this one system that represented like 85% of our infrastructure budget. I can't remember the amount of storage they consumed, but it was like 20 petabytes of enterprise class storage that they needed for all the copies of their database. That was, I believe, like 50 or 60 terabytes, but there were, a lot of copies of it across the environment and high availability and disaster recovery and development. They had to have the full copy everywhere. Your cloud bill will usually tell you what these are. While the cloud The cost management features of most of the major public clouds aren't perfect. They're pretty good at helping you isolate what's costing you the most money. And a lot of times, like I mentioned, this is going to be, your database server, your database service for your busiest application. They're big, they're expensive. If you're using commercial databases, the software for that stuff tends to be pretty expensive. You pay for it by the core, so as the workload grows, you're paying more for the software and the hardware. But look for those outlier workloads and let your bill tell you where these are. As I mentioned, you can scale resources up, but this costs money and there's an upper limit. As I mentioned, that upper limit's really high nowadays. 416 cores, 24 terabytes. I've never had a customer run on a database server that big. I was fortunate enough to get to test those for a customer, but those are some big resources. If you're running workloads like that, I want to talk to you after this because you're probably doing some kind of interesting things. But look for those outlier resources. Look how you can reduce them. The other thing I'll mention here, and it's not on the slide, but cache as much as you can. So if you can put a Redis cache in front of your database service, that Redis cache is probably going to be cheaper than your database service, and you can easily scale out that cache. You can't necessarily easily scale out your database unless you thought about that up front. So tuning queries and tuning your code is still going to be the best path to happiness. And the other part to this, from a database perspective, don't forget your database can have downstream effects on your other cloud costs. So I'll give you a good example of this. We have a customer who we've worked really hard with them to make their database more efficient, but they had some kind of major database inefficiencies, like really poor design, really bad indexes, bad queries. And because of that, they were using Amazon Lambda functions, which are it's a serverless compute model where you just effectively arbitrarily execute code. So you'll have some code that you don't really care on what server it runs on. But the way you're built for this is, how long the function runs and how much memory it consumes. Well, the problem was they had these really, really long database calls because the queries were so efficient, and they were returning a lot of data and not finishing and sending the results back quickly. So because the result sets were so big, because the queries were inefficient and the queries were running so long, their Lambda function cost became such a major portion of their bill that they weren't just impacted by the cost of their database, they were also impacted by the cost of those functions. So just some potential downstream effects that can happen there. Tuning queries and code is still the best path to your database happiness. So take advantage, and this is something I really like about the platform as a service offerings. They tend to give you a little bit more intelligence about what your busiest queries are and consuming the most resources. So even if you're not a DBA and don't want to go into execution plans, you can at least see what the long-running queries are, so you can have some focus into what you should focus on tuning. But definitely, if you can reduce that, you can reduce your cost at a few different levels. So my top tips for cloud databases, and the first is to think about scaling when you start designing your application. I can't emphasize this enough, especially if you're building a line of business application. Your usage patterns are typically going to be very predictable. You know roughly how much your specific business unit's going to grow. You know how many users you're ever going to have within probably 10 or 20%. When you start building customer-facing apps or you start building software as a service apps, it's super important to understand what that user profile is going to look like and what it could potentially grow to. And that's where you really need to think about designing things to scale horizontally, because you don't want to keep buying that bigger box. You want to have things scale in a robust fashion, load balance across, partitioning. Some of the NoSQL databases make this a lot easier. I'll say that for them. But at the same time, you want to think about that scaling from the beginning, because there's no data paradigm that's going to be easy to scale after you put it all in a single box, right? You need to think about that from the beginning. Likewise, choose the right services for your app. This is going to be a mix of your database, your data team, your development team, what they're comfortable with, what the needs of the application are. Is the schema in the application going to be changing all the time, where a NoSQL document database like Mongo or Cosmos might be the best solution? But it's whatever you choose, you need to kind of think about it from the early aspects. One of the things there, I will say, is cloud gives you more flexibility to add things after you've initially deployed them. If you want to add a Redis cache, sure, it's going to be some change to your app, but it is very easy to add. It's not like you need to go buy a new server. But think about those kinds of architectures from the beginning. Think about where your bottlenecks are going to be, and understand what those bottlenecks are going to be as you grow. Secure everything tightly. As always, pay attention to security. You don't want to be the next person to be hacked. The big thing I'm going to say from a database perspective is think about your network controls, especially if you're using PaaS services that maybe are by default open to the internet, or at least publicly available. Think about what that should look like and who needs to have access, and how you can lock down that as tightly as you can. Use best practices around least privileges. If you have data that's sensitive and you think you need to encrypt it, that's also something you want to think about from the beginning of your application. What is that data, and why does it need to be? What needs to be encrypted? How we're going to encrypt it? Where we're storing the keys? Those are all key kind of decision points you need to make at pretty early in your application's life cycle. Much like performance and scaling out, implementing security after the fact is a lot harder. So having multiple layers of defense in your security footprint is pretty important up front. Next, cache everything. And I really mean that, not just using Redis, but like if you're storing files and object stores, use a content delivery network for your application. Any place you can put stuff closer to the users and avoid hits to your B data sources is going to benefit you, and you're going to have less cost associated with those data hits. Also, pay your bill, and you don't want to not pay your bill. They turn off all your stuff. I've seen it happen. But pay attention to the bill. A lot of our customers put monitoring in place around their billing, and this is just to catch maybe suddenly somebody screwed up and turned the wrong thing on, and thousands of dollars are getting billed every day. You want to catch that before it's the end of the month and it's suddenly $50,000 that you've spent. And that's also, you want to pay attention to those normal charges, but that are outliers and look like they're really expensive. So that's something else to keep in mind. So to close out today's talk, data makes the world go round. If you're managing your company's data, you're one of the most important people in your company. You need to protect that data. Backups, availability, all those things are important. And one of the advantages of going to PaaS services is that some of that is taken off your plate. You don't have to necessarily worry about managing all that, and it can kind of improve your productivity to do more business-focused things rather than making sure the backups were successful. Monitoring in the cloud is mostly the same as on-prem, and even if you go multi-cloud, I think monitoring in and of itself still isn't terrible, but multi-cloud does make everything harder, whether it be security, monitoring, alerting, definitely for sure, all that network routing. Multi-cloud is not something that's simple and easy. And then finally, secure your data. Think about data security early and often. We live in a kind of a risky world with lots of ransomware attacks and nation-state actors. So thinking about how you can encrypt your data from the beginning of your application's lifecycle is something that's really important. All right, with that, do we have any questions, David?
Yes, we do, Joey. And first of all, congratulations on a great presentation. And also, I'd like to remind the audience that we can take questions up until about 5 minutes to the top of the hour in order to give you a short break before the next session. So please feel free to send them on in. Okay, this just popped in from Deval right as I said that. He says, can you share more details on scaling when our relational database is more write intensive and we can't horizontally scale it, as we can horizontally scale only readers and not writers?
That's a really good question, and that's kind of that hits the very crux of the point I was trying to make. You can scale writes in a relational database. The issue is you have to have done it at the very beginning of the lifecycle of the database. So effectively, in a partition model, you're partitioning your data. Like most databases have the ability to partition a table, which consists of making several virtual subtables. That gets you a little bit of write scaling to an extent, kind of depends on the nature of partitioning. The design you really want to see for a high write throughput application is not just scaling that data within a database, but scaling those data across databases. So effectively, you have a control database that sits in front of, I'm just going to use customer ID. Customer ID 1 through 10,000 would sit in DB1. Customer ID 10,000 through 20,000 would sit in DB2, and so on. And you're going to control writes based on the inbound customer ID. This isn't something you can just implement on an existing database. It's something you really need to be thinking about from the start of your database. So yeah, definitely if you're in a situation where your writes aren't scaling and you're in a single server solution, you don't have a whole lot of options other than to buy faster storage and more CPUs.
Okay. Next question comes from Jason in the audience. He's talking about backups and encryption. He says, is that a bad idea? We want to secure the cloud. What is the best practice to do this?
So typically, if you're using a PaaS service, your backups are typically going to be encrypted by default. I think almost all the database PaaS services that are running in the cloud do encryption. If you're doing your own backups, yeah, you can definitely, depending on your database, there are going to be different approaches to it. The big thing to remember when you're encrypting your backups though is whatever mechanism you're using for that encryption, you need to ensure that the key is stored somewhere that's A, secure and backed up, and B, accessible only to you, secured and accessible to you in the event of a failure. Because if you don't have the key and you have encrypted backups, you've effectively ransomwared yourself. So there is some precautions to take with that, but yeah, it's definitely a good idea. If you ever look at a backup file that's unencrypted, you can read all the data in it. And if it's unencrypted, you can easily restore it to a data, but you can also just find data in the file.
Okay, great. I'd like to remind the audience we have about 5 minutes to answer questions, so please send them on in. The next question in the Q&A box reads, what are the major inputs to your decision for which cloud data platform to choose?
Yeah, that's a good one. I like to think about a bunch of things like which scale I think the application is going to need. Like I mentioned, if you know you're just developing an application for a line of business, you have a really good idea of what it's going to be. If you're at a startup and you're developing something customer facing, you kind of have no idea how big it's going to grow. So you have those different considerations in mind. As an architect, I want to think about what the developers and the DevOps team underneath me are used to supporting in terms of do they have a strong familiarity with one specific database or another? And I would lean in that direction. And of course, you always have to think about cost. Like if this application that I'm designing is going to be very big over time, maybe I'll inherently want to start with an open source database because it's going to be really expensive to run SQL Server or Oracle. And, I don't want to have to worry about that cost 5 years from now when you have, 100,000 concurrent users.
Okay. Here's a quick follow-up from Jason, who earlier asked about encryption and backups. And he's just asking, does that just pertain to financial data or all data?
I tend to lean towards all data because everybody's got some sensitive data. So it's kind of complicated. a lot of times your backups can be protected at rest by your storage. So some of this just comes down to access control in terms of who can access the backups and things like that. Yeah, so I would say all data, the thing about financial data in particular, there are typically distinct requirements around financial data for it to be encrypted at rest. So it's a lot more common that you see backup encryption in those types of organizations. But in the current world, it's something to keep in mind. It's not necessarily the best protection against everything. Like access control is a far more important aspect of that.
Okay. Next question is about monitoring. It reads, can you explain more about cloud monitoring options and what they include?
So I kind of alluded to this a little bit, but typically the default options are going to be what the cloud provider can monitor from their control plane. So they're going to be able to see how many CPU cycles you're using, because at the end of the day, just about everything in a cloud is running in a virtual machine of some kind, even if you didn't create it. So they're going to be able to see memory, CPU, disk I/O, all that activity. Beyond that, they tend to offer more premium offerings that will collect data inside of those resources and give you a more complete picture of what's going on within a given resource, whether that be a database or an application server, either way. But those are kind of usually additional and not by default. So you may not even have to pay for it, but you definitely have to enable it.
Okay, well, as kind of a follow-on to that monitoring question, I moderated a previous session in which the presenter said, whatever you're spending on monitoring is worth it. What do you have to say about that? Do you agree? Oh, Joey?
I had to change the battery on my mic real quick. Sorry, I was down for a second. I didn't have hot over there. I tend to say whatever you're spending on monitoring is probably worth it, especially in a cloud world, because it's going to allow you to better identify outlying resources that can bite you, and you can better identify problems. You also want to know about downtime before your users do. You don't want to be surprised when you suddenly have users coming in that services are down. So yeah, I'd agree with that statement.
Okay, great. Looks like we have time for one more question. And it reads, how do you manage costs in your client's cloud environments?
Lots of Excel. Really, typically we just, the first swipe is easy. So just look for things that are unusually expensive or oversized. Look at workloads that are, the easiest way to save money in the cloud is by reserving VMs, compute resources for a year or 3 years. Those tend to be the hugest discounts. So if the customer knows that they're going to be running that workload for a long time, working with them to get those reservations in place, that's the low-hanging fruit. After that, it's really looking at the edges and seeing if there's dumb spend where they're not, where they, just waste effectively.
Okay, well, it looks like that's all the questions we have time for. So thanks again, Joey, for an excellent presentation and answering those questions.
No problem. Thanks, everyone.